Okay, so here's cycle 10, or phase 10, cycle K. So the area between curves. So if the graphs pass the vertical line test, we're going to use this top minus bottom formula. If they pass the horizontal line test, we will use this right minus left formula. Everything in terms of x here, everything in terms of y here. So if you look at this first example, vertical line test, they do not, the graphs do not pass this. So I hit the blue one twice, I hit the orange one also twice. Horizontal line test. Every horizontal line that passes through the region only hits the graphs once. Okay, so I'm going to use the right minus left formula. And they want us, okay, so find the enclosed areas, find the area enclosed by the curves below without using Math 9. All right, so without using Math 9 means use the fundamental theorem of calculus. Fundamental theorem of calculus. So I'll remind you what that is, but it's the thing with the brackets and the antiderivative. Okay, so I'm going to use this formula. So I'll write it down. So it's the integral from y equals a to b, right minus left, dy. Okay. So I'm going to have the integral from, oh yeah, so it's right minus left, so I'm going to do a vertical or a horizontal line. It could be anywhere. The horizontal line could be anywhere that goes through the region. That's the right function, that's the left function. Okay, now my y values, the lowest y is 0, the highest y is 1. Now the right minus left part, guys, I might want to simplify that, so maybe like off to the side, I'll do right minus left. All right, so this is like a little aside. Right minus left, the right function is, or it's not a function, minus 12y cubed minus the left one, 2y squared minus 2y. I distribute the negative. 12y cubed. Combine like terms. Negative 12y cubed plus 10y squared plus 2y. All right, so this is right minus left. So negative 12y cubed plus 10y squared plus 2y dy. Okay, now I'm going to use the fundamental theorem of calculus, which says that to find, the area, you take the antiderivative. So this would be negative 12 over 4 is negative 3, y to the 4th, plus 10 thirds y to the 3rd plus y squared. Okay, now I plug in 1. Negative 3 plus 10 thirds plus 1 minus, I plug in 0. You plug in 0, you just get 0. So this is negative 2 plus 10 thirds, negative 6 thirds plus 10 thirds is 4 thirds. Now you could use Math 9 to check your answer, and I did, and that is correct. Okay, so there's one when you're not using Math 9. We're going to do 2 more where we're going to use Math 9. Now, typically in the free response section, guys, they give you the graphs as reference, but a lot of times in the multiple choice section, they'll give you a problem where you're finding the area between 2 curves, but they don't give you the graph. You've got to get it yourself with your calculator. So, excuse me. Find the area bounded by the functions f and g in the first quadrant. You may use Math 9 here. Okay, so what you do is you graph them, okay, in y equals. To save us time, let me just show you that. I already did. And then I would graph it in a standard window to start. So I went zoom and then down to 6 for zoom standard, just to get a handle on it. All right, so that's the 10 over x. That's the parabola. Okay, now I want to look more closely. So they said in the first quadrant. So there's other regions, I guess there's other bounded regions that we could look at. Actually, no, this is the only closed bounded region that the graphs would make with these 2 points of intersection. There's more points of intersection, but none that are like, you know, the corners of a closed region. So I want to look at this more. So I want like my leftmost x, let's have my leftmost x be -1, and my rightmost x, currently my rightmost x is 10. Let me put it at 15. So my x min in my window is going to be -1. My x max is going to be 15. Okay, so window. So x min -1, x max 15. Okay. Now I can't see the top of the region, so let's have like my y min, the region is only in the first quadrant. So let me have my y min in my window be like -1, and I'll have my y max, right now my y max is 10, but let me have like my y max 20 or something. So y min -1, y max 20. Okay, so once you have your picture, well, or once you have your graph, you want to draw a nice, big, clear picture on your paper. Okay, so it looks like this. Okay, so that one is F, right, because that's the 10 over X. And then this one here, I'll put it up here. This one is G. Okay. Now, guys, the region, the bounded region is formed, you know, by these points of intersection as like corners of it. So I've got to find those points of intersection, and I will use my calculator. So to find those points of intersection, I go second calc, intersect. We'll go close to, kind of close to this one, hit enter 3 times, so 10, 1. 10, 1. Now I'll go to the other one. All right, I'm just moving closer to this. Hit enter 3 times, 2, 5. Okay, 2, 5. All right, so the region bounded by those curves is that right there. Now, which line test does the region pass? Not the horizontal one, okay, which is always good news. The horizontal situation is more complicated because you've got to solve for x. And if x is not already solved for, like it was in the last example, but if x is not already solved for, then you have to solve for it, and, you know. So vertical line test, yes, the region does pass that. The vertical line only hits each graph 1 time. Okay, so I'm going to have the integral x equals a to b, top minus bottom. How are you? I'm making a video. That's all right. I'm just going to finish, okay? Top minus bottom dx. Okay, and then, so this is the integral from the leftmost x is 2, the rightmost x is 10. Draw a little line. That's the top function, that's the bottom function. The top one is g, so that's -1/2 x squared plus 5.5x minus 4. And the bottom one is f for x dx. Okay, now to save us some time, I already, or that's all right, you want to go math 9 and open up this integral here and then type everything into it. And regardless of whether the variables are x or y, you only use x in your calculator. But when I did that, I got, where was it? I got 50.572 equals 50.572. Okay, I just got one more. Okay, now this one, Find the area bounded by the curves below. You may use Math 9. So this time, our graph, well, they do not, so we got this region here, it does not pass the vertical line test, okay, because it hits this orange one twice. So we're going to need to use, we want to use the integral from y equals a to b, right minus left, dy. Okay, so we need everything in terms of y, which means you've got to solve for x. So this orange graph right now was given to us like this. We've got to solve for x. So x equals y squared over 4. This one we've also got to solve for x. So I do negative 0.4 x squared equals y minus 2.4. Then I'll divide both sides by negative 0.4, so x squared equals y minus 2.4 over negative 0.4. Then I take the square root of both sides, and when you take the square root of both sides, you go plus or minus 2.4 over negative 0.4. Now, you have to ask yourself in this case, am I keeping the plus or the minus? Well, this region here is on the right side of the y-axis. So x's are always positive on the right side of the y-axis. So we're just keeping the positive one. All right, so that's what we're going to be using. Okay, and then you draw a little horizontal line. That's the right graph, that's the left one. And then you go the integral. Now the lowermost y is negative 4. And then the uppermost y is 2. And then the right function, this blue one, is this. So radical y minus 2.4 negative 0.4 minus the left one, the orange one, is y squared over 4 dy. Okay, and then you want to do Math 9, and when you do Math 9, you're plugging in, I already did it, it's right here. Now, even though there's y's on my paper, I plug in x's, and I got 10.8 equals 10.8.